Hello, hey everyone. Today we're going to have a look at running a full node inside a fairly fresh install of Ubuntu. I didn't install a completely fresh one. I've used this before to Gitian build Bitcoin Core releases, which is a different way of compiling a node, but or the Bitcoin Core software rather, I should say. But today we're going to run through it like it was a fresh install. So just going to type in my password there. What have we got here? We don't need to do any of that. So, excuse me. I think we will open a new window. Let's minimize this for now. Now I'm in a virtual machine here because I'm using a Mac, but that allows us to start from a more neutral place with less customization, and hopefully it will be closer to what anyone watching this would be using as a guide, especially if they're using a fresh install of Ubuntu. So let's make a new directory for where we're going to install this. So let's call this core node. And now we can see in that directory we have, core node. Of course we need to type the grep command. We now have a directory called core node. So let's go in there. And we're in here. ls shows us that we don't have anything. So the first thing we're going to need to do is clone the Bitcoin Core repository. So https github.com/bitcoin/bitcoin, and now it will pull in to a directory it's going to create called Bitcoin, all of the source code for Bitcoin Core. And this, we can check it, we can move to different versions. If this didn't work when you just typed in git clone, that may be because you don't have git installed yet. If you need to have git installed, you can just do this: sudo apt-get install git. You'll need to type in your password, of course, but it's already telling me git is already installed, newest version. You may not have that. You probably won't on a fresh install of Ubuntu, so you're going to need to type that in first. Let's head back here. Now we have a directory called Bitcoin. We can change into there, and we can see all the stuff here that we're going to use to build Bitcoin Core. Next, we are going to check out what's going on with Git. We're on the master branch. We want to check out the various tags there are. These are some of the oldest versions of Bitcoin Core, and we can go all the way down to the newest. So the newest at the moment I happen to know is 0.21.1 release candidate 1, and this is the speedy trial release candidate client. I believe in the next few days Bitcoin Core will release the final release for the speedy trial activation method of getting Taproot. But you can use older versions, and the compile process is pretty much the same for a long time now. So I'm going to press Q and come out of here. I'm going to press git checkout v 0.21.1 rc1. And now we can write git status, and we are now working here. So the first thing we need to do is go into doc directory. Let's have a look at the doc directory, and we're building in Unix. So let's take a look at that. We're going to type less because we want to read that file because it's got all the instructions. So less build Unix, and here we go. This is basically what we're going to do. Just those three commands there. Really, really simple, but it won't work immediately. What we need to do is install a bunch of dependencies first. So here we go. We can head up to, well, these are the dependencies, but there's going to be, okay, for Ubuntu and Debian, we can install all of these first. We're going to need those. So let's head over to here. We're going to do it from this directory, even though it doesn't really matter. Here we go. This should install everything. These are just some of the dependencies. And we'll leave that installing there. Looks good. Now, here are a bunch of other dependencies. Let's install those too. Hit Y. All I'm in is the README folder. And then, oops, I lost it. Where did it go? yeah, we've installed these, and SQLite is required for the wallet. So let's install that as well. We're going to copy, and now we're going to paste it. It might ask me to confirm, doesn't look like it's going to. Optional. Yes, we want UPnPC, universal plug and play. That helps. I've never found it does what I understand it to do, but that doesn't stop me from installing it anyway. What that's supposed to do is mean that you don't have to open ports on your Bitcoin on your router to connect to more nodes than the default 11, I think it is. Usually you'll only have one inbound node and the rest are outbound. So you're getting information from the network, but the network isn't getting much information from you. UPnPC should stop that, but it doesn't seem to do that for me. I might not be using something correctly there, and I'll do some more research. To build with Qt5, you need all this stuff. We're not going to build the Qt because it adds a lot of time onto it, and we're just going to run it from the command line. We're not going to run the full wallet. If you want to do that, just add this line. Simple. I have no explanation for what that does. Frankly, I'm just going to install it anyway. And next, well, we come down to the instructions for Fedora. Let's go back up and get the instructions for the Berkeley database, because that can often be quite annoying. I find I often get thrown off course with not having that installed. Berkeley database. Ubuntu and Debian have their own packages, but these will install Berkeley database 5.1. This will break binary wallet compatibility. You need version 4.8. If you do not care about compatibility, pass with incompatible BDB to configure. I might do that. I've found generally that I don't really want to do that for a guide. I think I'm going to make sure we do have Berkeley database. So where that's located is in the contrib folder within Bitcoin. And if you can see here, we have a script, a shell script that will install db4. So we type in /install, and what's the complaint here? Yeah, we need to specify the directory. So we will make it this directory. But I think actually if we do it from here instead, contrib/install, and then we do it there, we can do it in the Bitcoin directory rather than in the contrib directory. So let's do it like this. This can take quite a while. Hopefully it won't take too long, because I've allocated a lot of resources to this virtual machine, and it's running on a 32 gigabyte of RAM MacBook Pro. We should be able to build stuff fairly quickly here. So while it's doing that, I'm going to flip back here. I'm going to press Q to quit this README, and here we are. So we are going to git status again. We're in the right we're detached in the correct place, and we're going to start working on compiling core. Now that we've got all the dependencies done and we've installed Berkeley database 4. I'm going to wait for this to finish, but I'm ready to go. The reason I'm using two windows here, or two tabs in my terminal, is because at the end of installing Berkeley database 4.8, it's going to leave me some instructions for what I need to add onto my configure command, the second command. And I don't want to lose those. I don't want to have to copy and paste them out and then remember them, or go and get them later. I'm just going to leave them up in this window so I can take a look at them. These are the commands here. So first off, I'm going to run, there should be a command in here, autogen.sh. So we're going to run that script, /autogen.sh, and I'm pressing tab to autocomplete, just for anyone who's wondering. Now this should run fairly quickly. We should be done in about a minute here. Yeah. So we are now, what we're doing is, it's the, I believe it's a makefile script that we're running, and it's going to generate a bunch of stuff that we can use, and it looks like we're doing good now. We have db4. What's in here again? What does it say to use here? Berkeley database core node Bitcoin /db4. So this is going to be the directory that we use, that the configure needs to look inside. I bet it probably does, even if I don't configure it. If I don't modify the configure command. So yeah, this should just work. I really hope it does. Oops, need to come out of there. Press up twice. There we go. Now let's see if it works. It would be good if it works. I didn't add ZMQ. I should have added ZMQ because you need that if you're going to run the Lightning node. So here we hit a problem. Disable wallet to disable one because we don't have the compatible Berkeley database modified. We didn't modify this to explain where the BD4 stuff is. So we're going to do what the two commands here are. We're going to export BDB prefix to be there, which is where Berkeley database 4 is. It's in this directory it's in here, it's in this directory. So we've exported that. If I now echo BDB, can I tab complete this? Yep. So it's there. We've now added that. Now we need to configure this. Ignore these three dots here. Configure, and we're going to state explicitly where this thing is using the full path rather than the full directory rather than with a wavy line at the beginning. So here we go. Configure should work effectively now. I should have taken that opportunity to install ZMQ. If you want to install ZMQ, this is where you go. You can see depends. Where you need to go to contrib. And there's a directory here called ZMQ. So you can go inside ZMQ and you can install ZMQ. Well, actually, you're probably going to need, that's a Python script. So you're probably going to type in Python 3, ZMQ. What's the matter here? Import ZMQ. No module found. Okay, so you can get install I think it's lib ZMQ dot dash dev. I think it might be that. It might be dev 3. I can't remember exactly what it is. Let's open this up. Lib ZMQ install Ubuntu. Let's check it out. Install 0mq. What's the command? No, there's got to be something simpler than that. Let's try it like this. Brew install, that's for Mac obviously. Lib ZMQ3-dev. Okay. 3-dev. Knew it was something like that. There we go. Oh, we've already installed it apparently. So in that case, oh yes, it was already installed. As we can see with the configure command that I just ran, ZMQ is installed. So if we want to install Lightning on top of this, which is always great to do, we can do it. Configure worked successfully. So now we're going to run the make command, but we're going to modify it. I think we do it like this. I have 16 cores, so I can do J17, and that will do 17 processes at the same time. There you go. That's 16 processes. Every thread is being used. I am now hopefully going to be able to make this within 10, 15 minutes, something like that. And then what this is doing is creating the binaries for me. The binaries are turning the C++ code written by core devs into an actual piece of software, an application that you can run yourself. And that is your way of talking and interfacing directly with the Bitcoin network. If you're using a wallet without your own Bitcoin node, and you're using wallet software like Trezor's wallet or Electrum or something like that, all it's doing is talking to someone else's node, and then that node is going and talking to the Bitcoin network for you. Running your own node is the correct way to Bitcoin because you're talking directly to the network and you're not relying on an interpreter or another human being that you have to trust. You never want to accept Bitcoin unless a node you set up yourself is telling you that you've got those Bitcoin. If you accept Bitcoin from someone that isn't yourself, you're going to be doing that by default, but if you accept Bitcoin from someone paying you and you're relying on their interpretation of the Bitcoin network, they might lie to you. Generally, you're not buying Bitcoin from Trezor, for example. If you're buying Bitcoin, you're buying it from an exchange, and then Trezor are confirming that the exchange has just sent you some Bitcoin. It's unlikely they would lie, but again, it's a bit like gun rights in America. People say, why do you need guns? The government's not coming after you. And you say, exactly. You've confused cause and effect somewhat. The reason no one lies in Bitcoin is because everyone can verify everything all the time, so there's no point trying to lie. if no one ran nodes and no one verified what happened on the Bitcoin network, then people would lie again. And you have Ethereum. No, we're not going to go down that path. Bitcoin deliberately constrains everything it can so that it's easy to run full nodes. I'm doing this on a powerful MacBook Pro here in a virtual machine, but you can do it in a Raspberry Pi that can be bought for $80, $90 or something like that. Sadly, you still have to buy a terabyte solid-state drive, which is going to cost you about $150. That sucks. We wish it was less resource requiring than even that. We wish you could run a full node on, a hard drive. A terabyte hard drive is more like $40 or something, but unfortunately, it's just not realistic to use a hard drive. I've tried running nodes with a hard drive rather than a solid-state drive, and it takes over a month to sync. Mind you, that was with a Raspberry Pi 3, not the Pi 4s that exist today, so it couldn't work out. So anyway, here we are. We are compiling the C++ code. It's quite slow to do. My laptop is making, the fans are going absolutely crazy now. The autogen worked great. The configure worked great once we got past the Berkeley database hiccup. And this is the make command, and what that's doing is it's producing an actual binary, and you can run that binary from the command line, and it will that is your Bitcoin full node. It won't be like when you download Bitcoin Core from bitcoin.org, because then you're just downloading the binary from the get-go. You're not making it yourself using the source code. You're not compiling it yourself. The difference is, with what I'm doing here, I can read all of the source code in, let's go back in here. I can have a look at all of the source code in here, and I can read anything that's in here. For example, miner.cpp. I can read that, miner.cpp. Here is the C++ code. I can read it all. I can tell what it's doing. I can change stuff if I want. If I want my node to work differently to other people's nodes, I can change stuff. However, if I change stuff in a way that breaks consensus, then I can find myself forming my own network and breaking off. And that's what a fork is. And well, I'm not about to do that. If I was going to do that, it would be a very, very specific and a specific purpose or reason, and it would be some sort of activism within the community. And indeed, I am actually running my own forked node at the moment as my main client. I can perhaps make a video on that. There's an upgrade coming into Bitcoin called Taproot, and I disagree with the way Bitcoin Core have gone around it or launching the activation on the network. So me and some other devs have decided to make our own client that activates in a different way that is compatible with what Core are doing. If Core's activation fails, people will fall back most likely to our client because it's more insistent and it doesn't allow miners to deny us the upgrade. I might make a whole video on that, but I don't think I will be unless the approach Core takes fails, and Core are taking their approach will be beginning next week, roughly on around May the 4th of 2021. Miners can begin signaling activation using flipping a version bit that will be relevant to both my software and Core's software, and likely miners will just activate regardless, and we will have the Taproot upgrade live on the Bitcoin network, which will be very exciting. If miners signal straight away, they need 90% of blocks to have the version bit flipped within a 2-week period, which is one difficulty adjustment. And if that happens, we wait until November for Taproot to actually be usable. But once it's activated and locked in, once it's locked in for 90% of blocks to have that version bit flipped, there's no undoing that. It will be just a matter of time before Taproot becomes usable in the network. We still have to achieve one difficulty epoch where there's 90% of blocks where miners have flipped the version bit. So we've just now finished this. So we've finished the make, and I'm delighted with how quick it was on a Raspberry Pi. That will take about an hour. So we're going to go into SRC, and now we can look for the Bitcoin D. That is the client we just compiled. There is also a way to interface with it called Bitcoin CLI. Now we can just all we need to do now is just run Bitcoin D. That's what we're going to do. And there we go. That's Bitcoin. We are running. We just compiled Bitcoin from scratch. There it is. It's running. I'm not going to leave this running too long because I don't want to fill up my drive on my laptop, and I haven't gone into the config yet to tell it to prune, so it's going to start downloading gigabyte after gigabyte, and I'd rather it didn't do that. So let's just leave that for now. If there's anything you want to modify, if there's RPC credentials you want to enter or anything like that, I doubt you're going to be watching this video, but it's quite possible you are if you want to set up a Lightning node and you're wondering how to do this. If we go back to our home directory and we type in ls, we don't see anything, but if we type in ls-a, we've got the .bitcoin folder here. It's a .dot file, so we can go in there. Oops, we can go in there and we can see that, well, this is where all the data is kept for the Bitcoin blockchain and your wallets and everything like that. But we can also make a bitcoin.conf by touching it. Now if we type ls again, we see there's this file here, and that's going to be a text file where we can input stuff we want to customize our node. So if we want to customize it, I use Nano because I'm a pleb. This is just a text editor we've gone into, so we can write stuff like prune equals 5,000, and that will mean 5,000 megabytes or 5 gigabytes, and that will mean your node will only keep the recent 5 gigabytes worth of relevant information. And it will lose the rest. So it won't be a full node exactly, but it still will have verified everything, and you can still trust the information it gives you. This is great for if you don't have much room on your computer and you don't have an external drive, or you don't want to have it. Well, speaking of external drives, you can also do this. You can do datadir equals whatever. It can be whatever drive you want to put. So it can be in Ubuntu, I can't remember exactly how the file system works, but if I have an external drive, actually, let's check that out. There should be something in here. Where would I look for an external drive? No, that's not right. Where do I go? Dev in there. No. Well, apologies for not researching this first, but if you want to use an external drive, you just write datadir equals and then the directory of the external drive. Sadly, I don't have an external drive plugged in at the moment, so well, actually, I think that would be useful information. So I'm just going to plug in an external drive right now. Now let's plug it into Ubuntu. Now here we go. SSD 1 terabyte. Let's change directory into it. I can't remember exactly. Let's take a look here. I'm a big fan of Letterkenny. I wonder how I can do this. In fact, I can go cd there actually. Let's change directory to that. Okay, yeah, that's a bit of a pleb way to do it, but that's where the folder is actually. So I can go back here. There should be, grep media. There's a media folder. That's where Ubuntu likes to mount it. So we're not going into Gitty and user. We're going into, oh yes, we are. Of course we are. Then we're going into this SSD 1 terabyte. So there we go. That if there's a space in the name of it, you've got to escape the space with a backslash. So there we go. Now, if I wanted to use this, so supposing I wanted to make a directory for my Bitcoin stuff, I could make a directory in the external drive called full node video. I'm just going to call it that. Cannot create directory. Read-only file system. Oh, of course, yeah. This won't happen unless you're using a virtual machine like me. Even then, there is a way around it. But supposing you were going to do that. In fact, let's just list anyway. Supposing I go and I use this LK4. I want to put my thing in there. Let's go back here. I can use this whole directory here. /media /gitian user /1 terabyte. I can just do this. Gonna need that, and supposing I want to use LK4, I can just put the stuff in there. Now I'm not gonna do this because I don't want to screw up my external drive right now. So I'm gonna comment that out. There's other things you can do with your Bitcoin conf. Jameson Lopp has a great example. Bitcoin.conf. Let's go to Jameson Lop. He has a fantastic, where is it? Conf generator. Where is it? Should be in here somewhere. Where is it? Announcing the Bitcoin Core config generator. It's great that you've announced it, but I need the actual thing. We should have it somewhere in here. Can I click on this? Maybe there's a link to it here. Nope, that's just Jameson Lop's Twitter. Yes, here we are. jlop.github.io/bitcoin-core-config-generator. So supposing you want to do various things like where are some things you might like to do right off the bat? Prune old blocks, for example. This is the one example I already gave. Oops. Just remember the number pad doesn't work. It's going to show you what to do here. Prune equals 5,000. And it explains what it does. Maybe there's other things you want to do. Do you want to re-index? You can then add... where would that have shown up? It doesn't look like it's actually paid attention to that. Chain selection. Yes, you can go to testnet instead, for example, and then chain equals testnet will show up. So if you put that in your chain equals testnet, then that will also show up. But anyway, this is just examples of what you can do. You can create various settings. Now, if we go back here again and we run, well, we can't run Bitcoin D. This is one thing I should probably explain. Bitcoin D command not found. It's not in our path yet. So when we want to, what did I call this again? Core node. That was all right. CD Bitcoin, CD SRC. Now we can run it, but we're not running it as a binary that's in our path. So we can't just type Bitcoin D. We have to actually run the binary from this exact folder where it was installed. If you want it to be system-wide, which you're probably going to want to do, so you can just type in Bitcoin D from anywhere without having to go to the exact directory where the binary is, then go back to this folder again, which is where we've done almost all of the installation from, and type in sudo make install. Now, we haven't needed sudo for everything else, but that's because now we're actually putting the binary in a system deep path in one of the directories that we can't access without using sudo, or sudo rather, super user do. And that's going to put the binary in one of the directories in our path. The path, I don't know if I want to explain this right now, but here's the path. If you just type in a random command that isn't specifically executing a binary or something, or a script by typing /, if you just want to type in Bitcoin D, that's your terminal is going to search all of this stuff, or bash is going to search all of these directories for a binary that looks like that. We don't have that, and what this one command does, make install, is it just copies Bitcoin D and Bitcoin-CLI into one of these folders here, and that means you can just type it from anywhere. So you can do that. I'm not going to do that now because this is something I like to keep quite sanitized, because I've done some Gitian builds in this virtual machine. So I think that's a good place to stop the video. Thanks so much for watching, and yeah, have a great day, and let me know if there's any questions as well. Fantastic. Goodbye.